Welcome all. Today we are again with another video on join internals in PySpark. Let me start with a question. Have you ever written a join in Spark and thought, this is just one line? Why is my job taking 30 minutes? Today we'll answer that. Not by learning this syntax, but by understanding what Spark actually does internally when you write a join. So when you write a code similar to what you see on the screen, Spark does not run it immediately. Spark pauses and it creates a plan. And here's the important part. A join is not just computation. A join is the data movement plus computation. That data movement is where most of the performance problems begin. So for a join to work, Spark must bring the matching keys to the same executor. But data is already spread across machines. So Spark has to move data around the cluster. This movement is called shuffle. If you remember only one word from this video, remember this. Shuffle is expensive. So Spark creates two plans. One plan says what needs to be done. The other decides how it will be done. So the join strategy is chosen in the physical plan. That means Spark decides the join type, not your code. Now, Spark has multiple ways to perform joins. Some are fast, some are slow. Broadcast join, shuffle has join, sort merge join. Spark picks one depending on the data size and conditions. And yes, there's also a dangerous one. That's the Cartesian join. Usually, it's a red flag. Now, broadcast has join. It's the fastest join. So let's look at the best case scenario. One table is very small. Spark simply copies that small table to every executor. The big table stays where it is. Each executor joins locally in memory. So no shuffle, no waiting. That's why broadcast join is the fastest join. The Spark decides to broadcast based on the size. If the table is smaller than the broadcast threshold, Spark automatically broadcasts it. So by default, this is around 10 MB. You can also force broadcast, but only if you're confident that the table is small. Now shuffle has join. In this, both the tables are not small. Spark cannot broadcast. So it shuffles both the tables based on the join key. Each partition builds the hash table and joins locally. So this works only if the partition fits in the memory. That's why this join is less commonly used today. Now, sort merge join is the most commonly used join. This is the join you will see in most of the real projects. Spark shuffle both the tables. So then it sorts them by the joining key. After sorting, matching partitions are merged. Sorting is expensive, but this approach scales well for very large data. Now, shuffle is the real cost of join. So, let me be very clear here. Join are slow, not because matching logic, but because of the shuffle. So, whenever you shuffle, three things happen: network input output, because data moves across machines; disk spills, because data is written and read again; and waiting, because Spark must wait for shuffle to finish. That's why shuffle is expensive. So reduce shuffle and your Spark jobs become faster. Now shuffle introduces a stage boundary. That means shuffle has to stop and wait. Most joins create new stages. That's why joins look expensive in Spark UI. Now you know the reason that it's not magic. Now, how to see join types in Spark? My advice is never guess which join Spark used. Always check using the explain command. Spark will clearly tell you whether it used the broadcast join or it used the sort merge join. So this is useful in production and very important in interviews. So join optimization is again mostly a common sense. We should use the following steps. First is filter data early. Select only the required columns. Broadcast only the small tables. And avoid complex logic in join keys. So the logic is less data means less shuffle, and less shuffle means faster jobs. Now, most slow spark jobs come from simple mistakes. Mistakes might be we are joining huge tables without filters, or we are broadcasting tables that are actually very large, or ignoring the skewed logic, joining keys. So Spark is powerful, but it trusts your input. So in interviews, don't say I used joins. Explain how Spark executes them. Explain shuffle. Explain why one join is faster than the other. That's what shows real Spark understanding. So, if this made sense to you, that means you're thinking like a Spark now. So, keep learning and keep building. I'll see you in the next video. Thanks for watching.